Hello, welcome to Operations. My name is Josh Reed, and I'm a professor in the Operations group here at NYU. And today, what we're going to do is go over a little exercise, teaching you a little bit about first how lines form, and then a little bit more about how you can think about making capacity decisions. Queues are everywhere in the real world. We all encounter queues nearly every day, waiting in line to buy a train ticket at Grand Central Station, at a red light, going grocery shopping. Even on the internet, we encounter queues all the time, whether we can actually see them or not. Here are some numbers from a study done in England, where it was found that the average amount of time that somebody waits in line every month is somewhere around 5 hours. Grocery store takes an hour every month on average, waiting for a train or buses, 45 minutes, etc., etc., which multiplied over the course of your lifetime comes out to several months, which of course is something that we would like to reduce as a society, but it also provides businesses a lot of opportunity for improvement. That should increase your level of customer service and hopefully increase your revenues. In queuing theory, there's two main reasons why lines form. The first has to do with variability in service times, and the second reason is variability in inter-arrival times. So it's not necessarily the case that service times are very long or that too many customers are arriving at one point in time, but the more important thing has to do with variability. If you were to arrive to McDonald's and the person in front of you ordered 8 Big Macs, 8 fries, and 8 Cokes, that would obviously create a line in back of them, and you would probably want to switch lines. So that's an example of a long service time causing a line to form in back of a customer. The second reason why lines form, it has to do with variance in inter-arrival times. Imagine that a hockey team had just won a championship game and they all came to a restaurant at once to celebrate. Even if they all placed relatively small orders at the restaurant, that would of course cause a line to form in terms of people coming into the restaurant after them. Variance in inter-arrival times and variability in service times can both contribute to lines forming. Reducing variability in inter-arrival times and service times is one key way to reduce the amount of time that customers have to wait. Another equally important decision that firms have to make have to do with capacity and sizing decisions. How many servers or how many operators should I hire to work at the business that I'm running? Another factor that can influence waiting times has to do with arrangements of queues. So not necessarily how many servers do I have, but how do I arrange them in a smart or efficient way in order to serve the maximum number of customers in the minimum possible amount of time. Let's walk through a simple example involving David Craig, who is the made-up manager at our local supermarket. So David Craig is faced with the decision of how best to arrange the cashiers in his supermarket. The supermarket consists of 5 cashiers. Each cashier, on average, takes 3 minutes to serve a customer, and on average, 80 customers arrive to the supermarket every hour. So should he have a separate line for each cashier, or should he group the cashiers into a single pool with just one line in front of them? In order to begin to answer these questions, it's helpful to first make some simple, intuitive observations before we walk into making some actual calculations. One thing to notice, with separate lines, there's the risk of a cashier being free and not serving a customer while multiple customers are in the line for another cashier. However, if we have one single pool of cashiers, we will never run into the situation where there's a cashier free and a customer simultaneously waiting at the same time. For this reason, a single pool of cashiers is on average more efficient than having single lines, one in front of each individual cashier. Another benefit of having a single pool of cashiers, in the case of a separate line for each cashier, it's possible for you as a customer to have to wait for the customer in front of you to finish being served if they have a very long service time. On the other hand, if we have a single pool of cashiers, customers with long service times will be served by one particular cashier in the pool, but the other cashiers will still remain available to serve the remainder of the customers. However, there are several drawbacks as well to having a single pool of cashiers. Although it's more efficient than having separate lines, the average length of the line can be longer in front of a single pool of cashiers than it might be if we have separate lines for each individual cashier. Even though the line might move faster and you might have to wait in it a shorter amount of time, it still has the potential, at least on a psychological level, to scare customers away upon the first time seeing it. Another drawback of having a single line, as opposed to having separate lines, is that when polled in surveys, customers prefer to be able to choose which line to go into rather than being told that they have to get into a single line. These are all intuitive observations that we can make regarding the differences between having a single pool of cashiers versus a separate line in front of each cashier. But queuing theory also provides us with a more scientific way to actually quantify the differences between these two arrangements.